Good morning, sir. I'm presenting this final presentation of our project. Topic name is Design and Development of Robotic Cotton Picker and Effector. So, the mechanization in cotton harvesting. Uh, Basically, mechanization in cotton harvesting involves using mechanical devices like spindle cotton pickers and strippers to replace manual labor for faster and efficient and less labor intensive harvesting, which benefits in increased labor productivity, reduced harvesting cost, and higher yield due to better timing and reduced losses. In the country like India, where India stands second in the world cotton production during cotton season, yes, this data, the Ministry of Agriculture shows that Gujarat is at number one, then Maharashtra is at number two in cotton production. In the world, China stands first in the cotton production, then India, and then USA, Brazil, and other countries. So, there's a lot of scope in this project, and in developed nations, cotton picking is entirely mechanical. In India, the level of mechanization in cotton harvesting is near about 0% because cotton harvesting in India is done manually. So in this data, the level of mechanization in different operation is shown. So the challenges in cotton harvesting, the challenges includes like weather disruptions, especially rain and mud, labor shortages, and high cost associated with harvesting, field obstructions like stones and trash that damage machinery, pest and disease control that affects crop quality, soil degradation, market volatility, which means fluctuating cotton prices, high atmospheric moisture, and additionally, prolonged exposure to weather can also damage the cotton balls. Here in this, varieties that grown in India need to be picked multiple times, and the strippers and picker collect lots of debris. Lower picking efficiency of machines, and the cotton harvesting machines are of two types. First is mechanical and second is robotic. In mechanical, there are two types. One is picker and second is stripper. But in robotic, there's only a picker. Ways of cotton picking. If basically we see that there are only two ways. First is manual way by hand picking, and second is mechanical harvesting with cotton picker and cotton stripper. Hand picking is a selective traditional method that yields higher quality cotton with less contamination because we are using hand, and the person manually is gripping only the cotton ball. But in the mechanical cotton picker and cotton stripper, the machine actually carries carries and collects the whole plant sometimes, and a lot of debris in this. So there's a lot of contamination in mechanical way. uh, Hand picking also provides seasonal employments, but this process is costly and non-affordable because of market volatility. Mechanical harvesting contains two methods: cotton picker and cotton stripper. In cotton picker, which gently pulls the fiber from balls and uses rotating spindles to twist the cotton fiber from the open balls. The fiber then transferred to a basket and carried by the machine. Best for high humidity areas, but a cotton stripper which strips the whole plant, including branches and leaves. This requires a secondary process to remove unwanted plant material at the cotton gin. So basically, these two ways are not so effectively adopted in India. Both of these ways are not widely adopted as there's a loss of whole plant, and in this method we have saw that in India, variety that grown in India need to be picked multiple time. But if the stripper and picker is used, we are grasping the whole plant and a whole debris in it. So this way is not effective and efficient in India, as there is a loss of farmers. So people are using manual way to approach this. This is some kind of comparison between cotton picker and cotton stripper. But because of all the problems we have seen, to overcome all these problems we are desiring to go towards robotic ways of harvesting. So we are using a robotic cotton picker, and we are designing a robotic cotton picker is an autonomous or vision guided machine designed to harvest cotton, which reduces labor cost and waste by picking ripe balls and salvaging the dropped cotton yields. These robots use AI and image processing to detect and select individual balls, plucking them with the robotic arms or vacuum systems without damaging the plant, and aiming to improve efficiency, reduce waste, and address labor shortages in cotton industry. It works on AI with a combination of cameras to sense and detect the cotton balls. The process includes cotton ball detection, picking mechanism, and rover platform. The robot uses GPS for navigation. Once a ball is located, a robotic arm grasps the ball. It includes vacuum suction to pull the cotton. The picked cotton is then transported to collection bin. Then the key features contain the semi-autonomous electric farm vehicles that can move along the crop rows, that is called the rover or platform. Some system contains multi-robotic arms with advanced sensors and efficiency. Robotic pickers contribute to more sustainable cotton production. So the cotton ball detection involves using vision and AI, such as deep learning models like YOLO. YOLO means you only look once, to find retained cotton in medical context using ultrasound imaging. Uh, YOLO is a family of algorithms used to analyze images from drones or ground based cameras. Challenges in cotton ball detection: first is non uniformity in visual characteristics of cotton balls, and second is varying illumination, that the condition during harvesting operation, and third problem is complex background. The segmentation of cotton balls color, shape, and texture feature were extracted, and then the detection of the cotton ball can be done by image processing or CNN, that is convolutional neural network, which is the deep learning algorithm. But DL techniques is more accurate for real time detection. So these are some images which are used in detection, cotton ball detection. Methodology followed by CNN model development. So the CNN model development involves data preparation, including collection and pre-processing, which is the normalization augmentation of large label dataset. Augmentation means that the dataset which is already found or which is already available. So the second process, like data preparation, which contains data collection. Pre-processing is itself a big concept where structured and organized data is produced to improve model efficiency. Then dataset is increased by creating modified copies of existing images by flipping or zoom. Then resizing is done. So the data acquisition, data set preparation, model training, image labeling and data augmentation plays a huge role in sorry CNN model development. So the next thing is building convolutional structure of model. uh, to build a convolutional neural network, that is CNN, we stack convolutional layers and fully connected layers, incorporating activation functions like ReLU. After convolutional layers to introduce non-linearity, the structure begins by extracting low-level features with initial convolutional layers, followed by pooling layers to reduce dimensionality, then further convolutional layers to detect more complex patterns, and finally ends with the fully connected layer for classification or regression. So the first thing is input layer, second is convolutional layer, then activation function, then pooling layer, then fully connected layer, and our output is like output layer. So convolution, max pooling, all transpose convolutions operation, padding was applied to all layers, same dimensions as of input features. The ReLU activation function is used. Then training of the CNN model, which is a 90% image were used to training and validation, and the 10% of images for the testing of developed CNN models. The evaluation contains handling of overfitting and underfitting, means implementing techniques like weight decay or batch normalization. Then hyper parameters tuning is a process of adjusting parameters such as the number of epochs to optimize the model performance. Then lastly, trained model is tested to assess its accuracy on new unseen data. That's how a model is evaluated. The process used a supervised learning approach with labeled data. The training process contains backpropagation, optimization, loss function, and these are techniques to calculate the gradients changes of the loss function with respect to the network's weight. In optimizer, the algorithm called Adam that uses the gradients from the backpropagation to update the weight and minimize the loss function, thus improving model performance. Loss function then measures the discrepancy between the models dedicated labels and the actual labels of the training data. So the evaluation is done. Cotton ball picking mechanism. First, multi-end effector concept were considered in this study. We have used two finger gripper, mimicking human hand action when designing a developing end effector for robotic harvesting. First is gripping and second one is of picking. So and in second part, the 8 finger gripper is shown as of experiment. So the robotic cotton ball picking mechanism primarily use a combination of machine vision, AI powered algorithms and robotic arms with specialized end effectors to identify and physically extract mature cotton balls. Camera actually captures images of field to locate open balls, which are analyzed by algorithms. Robotic arms then move to this precise location to pick the cotton, often using the suction or plucking motion to detach it from the plant and deposit into the collection system. So here in this case, two finger, um, here in mechanical form, rotating spindles are shown. The first action is picking action and second is stalk among spindles. In fourth part, rotating pin paddles are shown. It did not ingest stems and get stuck like the spindle design occasionally. It contains before picking and picking. The red arrow shows the rotation angle. It does not ingest stems. But in rotating spindles, it did not bend the stem or damage the ball. But they also did not always remove all seed cotton from the ball, and doffing continues to be changed. A finger with moving pin belt is shown. So this is what we have designed for our system. The end effector was designed to transfer the picked seed cotton rearward and doff it. During preliminary testing, this device performed picking, then transferring and doffing procedures continuously. A finger with moving pin belt is shown here in the doffing area. The first two prototypes are um, the main part of the prototype. Third prototype with transferring capability, and the fourth prototype testing is done in the field. So the summary of the end effectors: we have considered many designs as two finger gripper, eight finger gripper, rotating spindles, rotating pin paddles, and lastly we have used the moving pin belt. So the considerations like picking ratio, transferring mechanism, doffing mechanism, penetration, exist, targeting, ball orientation, other issues and outcomes. When all these are compared, we are we have concluded that the moving pin belt is a strongest design and strongest experiment and strongest part of the robotic we can work on. So the choice of mechanism depends on factors like the cotton variety, farm size, and the desired quality of the picked cotton, as mechanical picking often results in lower quality fiber compared to the hand picked cotton. For efficiency and good quality, we chose multi-finger end effector, and in multi-finger end effector, we have chose the moving pin belt mechanism. So the seed cotton stuck in transfer zone at 18th test, and increased number of fingers gives the best gripping support. So we have designed a three finger moving pin belt. Increasing the number of fingers increases the picking surface area of the end effector. And fingers are, in the first view, fingers are contracted. In second view, fingers are expanded. This is the side view of the three finger moving pin belt. So fingers, tip and pin's dimensions, height of pin, diameter of the tip of the finger, and pin arranged around a circle with 120 degree. This is shown in this figure, and the distance to target during expansion is optimum distance need between end effector and target. So we designed a three finger moving pin belt with CAD modeling with Fusion 360, developed by an under actuated end effector with 3D printing, each featuring a moving belt with attached pins that pull and grasp the seed cotton mechanism is powered by a DC motor. Then we went for integration and testing. So the rover or autonomous platform. Navigation is we chose rover platform, which serves as the mobile base that navigates the crop field and carries a robotic arm. Sensors for ball detection and vacuum or grasping end effector to harvest cotton. It works with navigation, detection, localization, targeting, and manipulation, picking, transport, and repeating the process continuously, which have benefits like increased efficiency, expanded harvest window, and accessibility. The power and signal circuits of the robot. So in this project we have used different stepper motors, um, DC motor, that is servo motor, 6 limit switches. um, we have used the STM32 V4 microcontroller. Then we have used battery supply, fuse, and other things. Power and signal circuit comprise a power distribution system that supplies energy to various components like motors, sensors, and control unit, and a signal network that uses a microcontroller like an Arduino to receive sensor data and process it and send control signals to motors and manipulators. So this is the fabricated robotic harvester which we have created in our project. The fabricated cotton harvester is a robot which is designed for selectively picking mature cotton balls, utilizing image processing, machine vision, and often a vacuum based on based based to avoid damaging the plant or the delicate fibers. These robots aim to address labor shortages and improve harvest quality by picking only ripe cotton, reducing waste, and offering a more sustainable and profitable alternatives to traditional manual and mechanical harvesting methods. So this is the front view and this is the back view. These are different end effectors. This is a multi-finger end effector with a fin belt. This is a ballast weight. Linear actuators are used for uh, three-axis displacement. Power box is for the power supply. Then driver box as a stepper motor drivers. So this is the fabricated robotic cotton harvester. We have performed different tests on the field with the help of CNN. We are able to distinguish between the ripe and unripe cotton balls. So this is face to face, face to side, and face to back. Different tests are performed, and we have taken this case study called a robotic multi-ball cotton harvester system integration and performance evaluation by Shekhar Thapa and others in consideration during our project. So this is a robotic platform. Components like a small raid rover, Ackerman steering, 250 watt Pride Mobility wheelchair motor, then Cartesian type robotic arms with 2 degrees of freedom, and sensors like GNSS module, inertial measurement units like IMUs, 2 back wheel encoders, then ZED, 2 stereo camera for navigation in cotton field, dynamic window approach that concludes path planning algorithm. So this is our project. Cotton detection model and clustering algorithm, which we have seen in earlier. The camera is used for detection cotton balls and determining 3D coordinates, where the YOLO's 3 versions, which is YOLO V3, YOLO V4, are basically taken into consideration. Cotton ball detection model and clustering algorithm. So cotton detection done by the YOLO V4 model with ZED to stereo camera, and the second thing is distribution of detected cotton balls from with height based clustering. So the picking mechanism was like end effector and its control. So these are different end effectors, which contain voltage regulator, gear DC motor, end effector roller. In this design, pullback reel and its controller, which improves the interaction between the end effector and the cotton ball, and it has been integrated at the stop board. So the pullback reel is stopper board, and the end effector, vacuum conveying to transport harvested cotton from end effector to the collecting chamber. We have used vacuum. So overall algorithm of the robotic harvesting. First thing we did uh, is lab test. Then we went for a field test. So the results comes like this, and we can actually overcome manual way of picking cotton balls with this robotic way of picking cotton balls. And actually it is very easy if the machine is mm, properly made, and the farmer if teaches to use the machine, then it is very easy. Conclusion is like a picking efficiency of cotton picker and stripper was 85 to 90%, and 97 to 99% respectively. But whereas the trash content was of 8 to 10% and 28 to 30% in cotton picker and stripper. So to overcome this problem, we use a multi-finger end effector, and the result of YOLO model for cotton ball detection was precision, recall, and it was so effective. The average picking ratio of developed robotic multi-ball cotton harvester during field test was 56%, and average picking time per ball was 3 seconds. Thank you. Basically, in this project we have used a deep learning model, that is YOLO V4. That is you only look once for a cotton ball detection, which is highly effective for real time accurate identification of cotton balls. For clustering, hierarchical agglomerative clustering is employed to group the detected balls into the harvestable clusters, which improves harvesting efficiency by allowing the robot to collect multiple balls in a single pass. A system is designed to automatically grasp an object at one location and deposit at another with the help of end effectors, sensors, and control system. Involves various grippers like vacuum cups, magnetic attachment to secure efficient picking, and the overall algorithm of the robotic cotton harvesting, in which we have used multi-stage process that designs with machine vision, that is CNN YOLO 4 for cotton detection and localization. We used depth cameras for stereo vision. We used depth cameras for stereo vision, which is followed an agile algorithm that guides a robotic arm to position an end effector. A path planning algorithm directs the robot through the field, and for some systems, a hierarchical clustering algorithm groups um, balls for more efficient and multiple harvesting. So finally, the harvested cotton is then collected into the receiving device. Here is a vacuum canister. In that, the harvested cotton is collected, and with the help of these tires, uh, it actually moves. These are connected to different motors. Then it is connected to actuators, and the whole system is fully integrated and developed. So the results are uh, expected, and we can actually overcome over the manual way of cotton harvesting to this robotic way of harvesting. This project shows that the precision is there, accuracy is there, and uh, picking ratio is increased, as well as the average picking time per ball is also increased. So this is all about this project. Thank you.